Welcome back. I'm glad you're here. Okay, so we're going to extend further, deeper into our discussion of the nervous system. And I said that we were going to talk about gradient potentials, and we are. But before we do that, I'm going to walk you through the plot of what's happening when we're talking about membrane potential. What at each point as the membrane potential changes, what's happening in these sequences, these steps that we've talked about. First, okay, I put in my AirPods, so hopefully you can hear me better. There's a lot of other noise happening. Okay, so we stepped through what's happening when an action potential, a wave of action potential moves down an axon in our last lecture. What we're going to do with this lecture is relate that to that plot. So I introduce you to the plot, and I explained that we're going to see this a lot. It's not showing up. Hang on. What is going on? There we go. I explained that we're going to see this plot a lot. We'll see it a lot when we talk about the nervous system. We'll see it also a lot when we talk about muscle contraction, particularly when we talk about skeletal muscle contraction and when we talk about cardiac muscle contraction, because the plot is going to look different for each of those. So when we're talking about neurons, where we first start learning about this whole action potential depolarization, repolarization situation, our resting membrane potential is negative 70 millivolts. So this is where we start. And if you remember, primarily the sodium potassium pump is what gets us there. We start at negative 70 millivolts. This is the resting membrane potential of our neurons. So this is where our body just kind of tries to keep our neurons hanging out all the time. Try to hang out at negative 70 millivolts. Okay, then I'm going to use a different color here. Okay, so we're hanging out at negative 70 millivolts. And then what happens to change that? We're at negative 70 millivolts, and something's going to happen to start moving that cell, that membrane potential, start changing it. It's going to start making it more positive. What happens? What is that? Okay, so we have to have a depolarizing stimulus. If we're going to get to an action potential, what we have to have is a depolarizing stimulus. So let me think about the best way to do this. Okay, so number one is our resting membrane potential. Something happens here at number 2 to change that. The thing that happens at number 2 is a depolarizing stimulus. So a stimulus that is going to cause the membrane potential to go more positive. Right now it's polar, so we've got negative and positive. A depolarizing stimulus moves the charge closer to equality, depolarizing. So we have a depolarizing stimulus. So where does that depolarizing stimulus happen? Where do we have to have that depolarizing stimulus occur? Okay. Depolarizing stimulus is going to occur on the dendrites of the cell body. Okay, as we're climbing, the interior of the cell is changing in charge. It's becoming more positive. The next step in the process is that have to reach threshold. Okay. Oops, that's 3, not 4. Threshold. Okay. Where does threshold have to happen? Can it happen just anywhere in the cell body? Is it reached in the axon terminus? Is it reached in the axon? Where do you have to reach threshold? Okay. Threshold has to be reached at the axon hillock. And what is threshold? So up on our y-axis, where are we over here? We have to reach negative 55 millivolts. We have to reach negative 55 millivolts at the axon hillock. Okay. What does this trigger? So what happens when we reach negative 55 millivolts at the axon hillock? That triggers rapid depolarization. Okay. So we have rapid depolarization here. Okay. Rapid depolarization is produced by what? Okay. Rapid depolarization is triggered by the entry of sodium. So we have a rapid flow of sodium into the cell. And now we are at the very beginning of the axon, just after the axon hillock. So now we're depolarizing, 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 depolarizing. And when we reach sort of the peak of this depolarization, what we have is, I can write it over here, is our sodium channels close and our potassium channels open. So up here at the peak, okay, our sodium channels close, our potassium channels open. What does that do? That triggers repolarization. Okay, so sodium channels close, potassium channels open. This triggers repolarization. So here we have potassium moving out of the cell. Repolarization. So we're repolarizing. Okay, cool. We're moving into the potassium's moving into the extracellular fluid. This causes that positive internal environment to start to come back down to a negative internal environment, and that continues. We come all the way down and actually go a little bit below that negative 70. And this is because those potassium channels stay open. They stay open longer. And so lots and lots and lots of potassium leaves the cell. And so the cell, when it repolarizes, it actually hyperpolarizes a bit. So we have hyperpolarization. hyperpolarization of the cell. And then we have potassium channels close. So potassium channels close, and now we're going to get the reestablishment of our resting membrane potential. Not sure. So here, we'll put that down here. 8 potassium channels close. But if they just close, then that shouldn't bring us back up a little bit more positive, right? The way that we get a little bit more positive is that potassium enters through leak channels. And then, I guess I could have done that right. And then, so our potassium enters through the leak channels, bringing us back to our negative 70 millivolts. And then extending this out, now our sodium potassium pump does its thing. Oh, that is not how you make a U. Does its thing to maintain resting membrane potential. Cool. Okay, so those are the steps following that curve of what's happening to membrane potential as we move from a graded potential into an action potential and then level back out into our resting membrane potential. So what's involved in what is kind of what that plot is showing us. And then next, now we're going to move and we're going to start talking about the synapse. And when we're talking about the synapse, that's where we're going to dig into a little bit more about the graded potential.